Hi, this video is on question number 6, 2021 AP Calculus AB exam. A medication is administered to a patient. The amount of milligrams of the medication in the patient at the time t is modeled by function y equals a of t. The differential equation for that function is given to us, and at time t equals 0 is 0 milligrams of the medication in the patient. Portion of the slope field is given below. Sketch the curve through point 0, 0. So all we really need to do here to make this happen is just sketch a curve that's going to pass through the origin and kind of goes with the flow of the dashes. So there's no specific requirement, but we need to make sure it kind of turns with that. And over here it's very important. You see it definitely have a horizontal asymptote at these values, so we need to start approaching that. You cannot cross any of them. Okay, so that's all you really need to do for part A. Part B, using correct units, interpret the statement that is going to be that the limit A of t as t approaches infinity is going to be 12 in the context of this problem. So what does that mean? If we second. So what we need to understand is that this represents the amount of medication in the patient. So for part B, this means that as time goes on, the amount of medication in the patient approaches 12 milligrams. That's all you need to do. Okay. It does ask you to have units, so it is important that units are included. Okay, and that's what's going to need to happen. So part C, it is asking you to use separation of variables and solve this particular equation with the conditions 0, 0. So what do we know? We know dy over 12 minus y is going to equal 3 dt. That's separation of variables. We can go ahead now and integrate both sides. And that's going to give us negative ln of the absolute value of 12 minus y equals 3t plus c sub 1. Okay, so ln of 12 minus y absolute value equals negative 3t minus c sub 1. So absolute value of 12 minus y equals c e to the negative 3t. It's the easiest way to solve that because you're going from logarithmic to exponential form. It's a lot easier to do it this way. So we have some other c, not the same c as I used earlier. Now we can use the initial condition, which is 0, 0. So that means that the absolute value of 12 equals c times e to the power 0, which effectively means that c is 12. So we know we don't need the absolute value anymore because the values are going to be positive. So we can drop that. So 12 minus y equals 12e to the negative 3t. And we can rewrite that for y. So y equals 12 minus 12e to the negative 3t. Okay, and that's all.